Hello, everyone. So my name is Peter, and I work at Gnosis. And today I will present a new project from Gnosis AI that's aiming to make safety and security on chain for everyone as easy as possible, especially for the end users, so the day-to-day users of on-chain. Because nowadays, the AI agent in Web3 are just booming, right? There are so many projects about using AI, making it agentic, everything from predicting the future with prediction markets, to governing those, up to the some entertainment like streamers, tweeters, etc., etc. And this is great. So I'm actually a fan of many of these projects and working a lot with them as well, while developing them as well. However, what we thought is a shame that there is not much news about the security point of view. So usually when we hear about security in Web3, it's about like ZKs and verified LLM outputs and similar stuff. And that's, of course, very important. And I will also show later in the presentation why. But here, I will be talking about security from the daily user point of view. Because usually how it is, when we are onboarding someone into the Web3 from the Web2 space, then let's say the first wallet that you will find out on Google is MetaMask. So you just install the MetaMask. It will give you the seed phrase. You have right away your public key, private key, and then there is a little bit of confusion because how it goes usually is like, here's your private key, here is your seed phrase, and make a backup of it. So make a copy, place it somewhere where you can find it, because if you lose this, if you don't have the access to this, there is no one who will help you. And basically, you lost all your funds. On the other hand, kind of contradictory, actually, perhaps don't make so many copies and don't just leave it at home somewhere where everyone can see it, because you have a malicious party, you have a party, there is a lot of people, someone will see it. If they get hands on it, then you are doomed again, because with this, there is no one who will actually stop them from draining all your funds, doing whatever they want with it. And then there is Safe. So the small wallet like Safe, and they are great because they are solving many of those problems for sure. So with Safes, for example, you can have multiple signers. So if you are a team at the company, then you can have a rule that your Safe needs at least 2 signs from owners to execute the given transaction. Such that multiple people need to see it, and no single malicious party can do anything wrong, even if a single person is hacked. Or we have spending limits. So if you have like a life-saving account, then perhaps you can have a spending limit and say that you can spend just some small portion of the funds on day-to-day basis to somehow limit the possible loss that can be made from hack or something else. And of course, stuff like account recovery. So if you are onboarding a family member, then, for example, a family member or someone who really trusts you, that they can make you able to recover the account if it happens that they lost it. That actually, I guess, happens a lot. I'm not sure about how you guys, but anytime when I'm helping with something back home for my family, they always lose the password, never remember it, we need to recover it, etc. And I think everything like this is heading in the right direction. We also have the Pectra, and with Pectra, like even AOAs can become a smart wallet. So again, that's great and heading in the right direction. However, there is still a lot of stuff that's judged by the end user. So stuff like scam tokens. If the user is going to buy some token, it's up to him to judge if this will have any value tomorrow. Or stuff like bind signing. So even though you have multiple signers in your Safe, they need to manually verify what the transaction is going to do or not to do. And nowadays, I guess the average Web3 user is quite technical, so perhaps it's not so big problem, but still it happens that people are in a hurry, they just miss it and then sign something that they shouldn't. So with Web3, even a small, potentially unimportant transaction, like sending $1 to someone, can have a disastrous effect if your computer is, for example, hacked, and they will just switch the transaction for something else, then people will miss it, sign it, and everything is done, which, of course, is something that happens. Well, sometimes happens. And the thing is that in Web3, there is no centralized entity that could be blamed, like, hey, you should have done something to prevent this. So it's up to the end user, and usually we just say, like, hey, you should do better. You will see the transaction, you will see what it's doing. So it's up to him, and let's just move on. However, and that's kind of like it is. However, in the standard banking systems, there are bank centralized entities that usually do some kind of job to prevent this. However, in Web3, it's not the case so much. So natively in Web3, you have the private key, the seed phrase, and with that you can do whatever you want. However, in the standard banking, as I said, there is the bank, and if we assume that you have some reasonably developed bank, that you are using some reasonably developed bank, then they are doing a lot of checks for every transaction, login. If you are logging from your computer, from your location, if your credit card is suddenly being used from other part of the globe, then they will most probably block such transaction. Or perhaps if you are going to pay at some e-shop, there's a lot of fraudulent activity, or not fraudulent activity, but a lot of complaints about them, that the bank can stop the transaction, and under an hour you will get a call from them that, hey, we blocked this, are you sure you want to do this? A lot of users are complaining, perhaps you shouldn't. And so that actually happened to me as well in the past. And so there is a lot of algorithms, hard-coded rules, machine learnings, basically AI, that are taking care of this and escalating this to the humans in the end. And with this in the mind, I would introduce an agentic cosigner from Gnosis AI. So basically what it is an agent running 24/7 on some server. It can be your computer, it can be cloud, it can be Gnosis Cloud, whenever. And it's monitoring your transactions 24/7, the whole day, the whole week, the whole year. So how it works in Safe is that if you require multiple signers, then when you create the transaction and you are the first signer, it goes to the queue. And from this queue, anyone can pick it up and add a sign if they are owner of the safe. And that's exactly what the agent is doing. So as soon as you create a new transaction, the agent will pick it up and will give you near instant feedback about it. So it will check, hey, are you interact with some potentially malicious addresses, some addresses that are reported that are being used by scammers or something similar? Or is there any odd behavior compared to your history? So you have some history of transactions in your safe, and in the case that the new transaction is somehow odd, we will see how odd, as an example later in the slide, it can block it. And there are many, many more checks. I will show some of them later on, but that's the idea on a high level of view. And in the end, the agent will either approve or decline the transaction. But in any case, it will send you a side message to your safe, such that you can do the final decision whether you want to go with this transaction or not. So how can it look like? Here is an example of a message sent to the safe from the agent for transaction that seems to be okay. So let me read the first line at least. It's saying, everything is okay. The transaction involves a swap of 250,000 euros for USDC with no indication of malicious activity. All security checks pass, and the transaction is consistent with the previous legitimate operations. And then you also get the list of all the various checks that the agent did. And in this case, you can see that even though 250,000 euros is quite a lot of money, so it's not a small transaction, however, there is really no potential maliciousness in this, because if we are just swapping one well-known stablecoin as yours to another well-known stablecoin as USDC, and at the end of the day, all those money are remaining in your safe. There is not much that can be wrong about it, so agent can just approve it. And here, we have an example of potentially malicious transaction where the agent is saying the transaction is flagged as potentially malicious due to the large amount, almost 12,000 euros, being transferred to a new recipient address that has not been observed in previous transactions. And so this is another clear example of when something can go wrong, because when you are, well, 12,000 euros is much lower amount of money than the 250,000. However, in this case, the agent has no idea who this other recipient address is. So it can be your friend, it can be your new employee, or maybe you have been hacked and someone is withdrawing all your money to their own safe. So who knows? Agent doesn't, so he will decline the transaction. And so this example, I'm kind of black and white. So swapping something is totally fine in that case. This is potentially malicious, but then of course there is this big gray area where, well, it's hard to say, it's hard to interpret, and that also when the agent can come in and give you some details about the transaction that you are going to do. And this is how it looks like. In the case he thinks the transaction is malicious, so he will not approve, and actually he will create an on-chain rejection. So in Safe, when you create a transaction, so basically propose a transaction, you can also reject it afterwards by creating a transaction with the very same nonce. And this is how it looks like then in the interface. If the agent created a rejection, you have received a message, and now you have the choice. You can either confirm the rejection, so you can say that, okay, agent is right, I will rather not go through with this, or you can say that, hey, that's a false positive, I don't care, agent, I will approve it anyway by some other owner of the safe. And so that means that while the agent is there to somehow help you, guide you, and give you information about the transactions that you are doing, he is not able to actually block you out of your safe unless there will be some misconfiguration, but he's not. So to sum this up, it's an agentic cosigner that's completely open source, and you can either go to the URL down there or scan the QR code. And so that means that while you can trust the agent that Gnosis is running, you can also just clone the repository and run your own agent as well. However, in any case, it's good to mention that the agent's permissions are limited. So even if you add it as a cosigner, it doesn't mean that he would be able to steal your money or do any malicious activity there. And in the future, the access will be even more limited than it is now. However, still, it's kind of a big ask to say to someone that, hey, add this agent, this cosigner, because, well, that's basically access to your safe. So for that reason, before you actually do that, you can also try it out either with APR or web application that's also in that QR code. Because safes are on the blockchain, that's public, so you're able to copy-paste any safe address on either Ethereum or Gnosis chain and verify any transaction that's currently queued, or even the historical ones if you just want to check out how it looks like, how it performs, what kinds of things it says. Yeah, and currently it's on Ethereum and Gnosis chain. However, it's just EVM compatible, so in theory you can run it on any chain where safe is deployed, and that will be totally fine. So that was kind of summary. Now we can check out some details and perhaps future plans. So what attack vectors does the agent check for? I would split it into 4 groups. So the first group are hard-coded rules. So various checks that are just programmatic and hard-coded, such as hash verification. So does the hash of the transaction matches with the ones that are coming from API versus the one that agent creates by itself, or some blacklist of addresses, like public keys that are published by governments because they were related to some big scams, hackers, etc. Then the second group is not yet implemented but coming soon, and that's a transaction simulation. So the agent will actually execute the transaction and sees what it actually did and make a decision based on that as well. And the third one are is LLM analysis. So, and I would say that the first three groups are either free or very cheap to run. So the first and second is free, and the LLMs, well, the costs are going down every month, and you can even run your own local LLM. So that means that the cost of running the check is very, very low, and you can verify the transaction under a few cents at max. So unless you would be doing like thousands of transactions per day, which is, I guess, unlikely, it's very cheap to run and use. However, then there is also the fourth group, because the agent is meant to be very extensible. So it means you can implement any integration, any check that would you like to do as well. And we have some integration with third-party APIs as well. So the GoPlus and Cybers are companies who specialize in blockchain security, and they expose some APIs about the other security, NFT security, safe transaction security, etc. So if you like to, you can also plug in some third parties or create your own module to check, and the agent would use that as well. And that would be about what's possible right now. Let's check out what perhaps we will implement it in the future. And the first thing are circles. So this kind of looks like a slide from different presentation, because it is, but to quickly introduce you, so I can get back to the agent. Circles is a new monetary protocol by Gnosis. It was launched a few weeks back. And if you didn't hear about it, then perhaps it will be too much information, but I encourage you to go and check it out because it's super cool. And how it works is that instead of the money, like Bitcoin, Ether, etc., being issued by the miners, validators, and so on, how it works here is that anyone can join the system and anyone can issue the circles. So basically, tokens, the money in the system. So if you join, then every hour you are able to create one circle, basically one token, one kind of your money. However, then the question is, if anyone can join and anyone can issue the money, how you can make sure that there are no bots, fake accounts, some farm bots, some malicious actors, etc. So how can we assure that someone will just not create hundreds of accounts and basically become a circus billionaire over the night? And how that works is a trust network. So in circles, in order to someone accept your money, so in order to you to be able to pay to someone, they need to give you a trust. So if you give someone trust, that means that you are accepting them as a real, non-malicious person, and you're accepting their circles. Because in the background, every person has their own kind of circles. On high level, there are just circles, so you can have 3K of circles. But on the implementation level, there are many kinds of circles. And how that works in this example is that we have three persons, A, B, and C, and A and B is trusting each other, and B and C is trusting each other. That means that B is willing to accept A circles and C circles, but for example, A is only accepting the B circles. So what does it mean in practice? Is that if, let's say, the person A wants to send circles to person C, but they don't know each other, they never met, it can be just a coffee shop owner or something similar, it doesn't mean they necessarily need to give each other trust right away, because there is an intermediate person between them, and we can create a pastor. So that means that if A is going to send circles to C, A circles go to B, and B circles go to C, and everyone is happy because everyone has the money they trust. And this is how the network is growing. So in the beginning, there was few people, but it's growing, growing, and growing. And you can see that there is some dense graph, but at the same time, there are some small communities that we don't know if they are like fake accounts just trusting each other, or perhaps some real small community. But it doesn't matter so much. The idea is that we could use the circles trust graph in order to verify the transaction. So if you are sending money to a completely new person, to a completely new public key, instead of just saying, hey, we are not going to accept this because we don't know the person, we can check the circles trust graph and see if there is some strong trust relationship between you and the third party. And if yes, based on how strong it is, we can either accept or decline. Or the second cool improvement would be, once we have some data to train our smaller, faster, cheaper models, that will be also verifiable. Because approving of the client transaction is certainly something where we want to verify the LLM output. However, with big models provided by OpenAI APIs, it's not really possible. So if we train something slower with the data once we have them, that will be pretty cool and very useful and scalable into the future. And even more in the future, what would be super nice is instead of asking you to add a cosigner to your safe, to have some deeper integration. Because adding a cosigner, yeah, that's kind of scary. And also people need to be introduced to the MetaMask, to the safe, and now to the agent, so not great. So if there will be some deeper integration by default into the safe or blockchain, that will be pretty cool. And the users would have some kind of feedback about the transactions. And hopefully I got the 1 minute right. So that's about it. Again, the QR code for the SafeWatch agent. And if you have any questions, I'm here for you.
Thank you so much, Peter. Everybody give a hand for Peter. So safety in everything is so much needed at this time, especially when we have everybody. I have one small question. When you talk about circle of trust and you send between people, and those are the ones that validate you, what happens when one of them might become malicious?
Well, that's a good question. So you should watch out for that. So if someone becomes malicious, you should just entrust them and minimize their losses. But ideally, you should trust people that you already know that won't become malicious. But it's a great question. It's a big deal how to do this. Because either you can be very pessimistic and just trust your best friends, but then we won't have these trust connections with the world. Or you can trust everyone, but you will end up with a bunch of fake circles that no one really wants. So you need to find the right middle way.
Well, what I'm asking is, many times the people you think you can trust the most are the ones that's going to backstab you first, right?
That's true.
That's the thing. So you think people are close, and actually the ones that you think is the ones you bad is actually ones that you could trust more than the others. The world has become a weird place.
Yeah, well, yeah, that's true.
So we have 2 questions on board. First, I want to ask, do anybody from the audience in here have any questions for Peter today? Else we're going to jump directly into the questions. So let's go with the first one down here. Why is fraud prevention still so underdeveloped in Web3?
Yeah, that's what I'm asking since I'm in Web3. So I have no idea. And even this was super simple to start with, so it started as a simple experiment. Like, hey, let's try to build this, and it actually worked. That's why we are here, and perhaps it will take some place in the future, perhaps not, we will see. But why it's underdeveloped, I don't know. It would be super good if it wouldn't, right? So maybe this will spike the interest.
The strange thing, fraud has even become bigger in Web 2 even the banks and everybody, because everything has become smart use and sign on phone, and all of a sudden your bank account, oops.
Yeah.
Basically.
Yeah, that's true.
So the other one goes very much into who should take the lead in bringing fraud detection to Web3, dApps, wallets, or protocols?
Well, I think it would be very nice if some, like perhaps Ethereum Foundation, someone who is actually developing the blockchains, takes some lead in this to somehow go big.
Go big or go home?
No, go home. We can start small. Why not? But actually, yeah, going big and put a lot of effort there. Put some motivations for people to actually build it, to actually use it. That would be nice. Right now, it's kind of, if you blind sign, it's your fault. Sorry, go home. But hey, we can actually do something about it, so why not? And it's not so hard in the end.
The reason why I think this is good is because many times you see the people with the best intentions in the space are the first ones to get completely grilled because they're trying to do this and really do better for everybody else. And they're like, no, we want to be anonymous, 100%, right?
Yeah, well, I think we can skip anonymity and zero and have some safety protocols in place. Like, why not? It's not going against each other. Of course, with centralized banks, it's much easier to do some fraud detection. But hey, we can do at least something, right?
Yeah. So, audience, you have one last. There we go. I think it just went down and in again.
Yeah. Hey, I have one question. You said earlier that you can give to the agent the cosigner possibility to a safe wallet. Let's say we have a safe wallet with 2 out of 3, and I have myself and 2 agents with different wallets. They can take their own actions, right? And they.
Yeah, that's true. So ideally, don't do that. So that was I was also talking about like some deeper integration into Safe, into blockchain somewhere, because right now, yeah, you have a cosigner, and what could also happen is that you are the signer, you add the other cosigner, the agent, and there are just two of you, so you can be blocked out. So there is still some stuff that you need to pay attention to while configuring this. So ideally, we can do better in the future. Right now, we have this, yeah.
All right, so they can call, they can throw me out. I was thinking of, I don't know, give them a free will to trade or something, or use the wallet for.
Yeah, but the question is, why would you add a second agent if you have already the first one? So hopefully the first one should be good enough.
Yeah, I just wanted to see if you say that they'll throw me out of the party.
Yeah, so their permissions are very limited, so they cannot steal for you, they cannot be malicious, they cannot just create a cooperation between them to take out your funds. However, if you misconfigure this, yes, you can be blocked out, and that needs to be improved, yeah.
I'm gonna laugh once he loses wallets to the agents. All of a sudden, AI is taking over all his wallets. Well, for this time, Peter, we want to say thank you for coming. Please, everyone, give a major hand for Peter.
Thanks a lot.